Good day, everyone. So, welcome back to my YouTube channel. So, today I want us to have a look at the universal gravitational law, right? Before we start, don't forget to subscribe on our YouTube channel and also leave a comment in the comment section. All right, let's get to it. Okay, so the first thing that you should understand under this topic is to able to state the universal gravitational law, as that is always be the first mark that they give you when you are writing an exam. So the universal gravitational law states that every particle in the universe attracts every other particle, right, with the force that is directly proportional, right? The force that is directly proportional to the product, right? To the product of the masses, and inversely proportional to the square of distance between their centers. Okay, so this actually means that F this, right, it means that the force or the gravitational force, I can call it Fg, right, is directly proportional to the product of the masses and inversely proportional to the square of distance between their centers, right? So this means that if I'm plotting the graph, right, of Fg of the of m1 times m2 versus Fg, I should get a straight line like that because they are directly proportional to one another, right? Which simply means that if the gravitational force, right, increase, also the product of the masses will also increase, or if the product of the masses increase, also the gravitational force increase, right? But if I'm plotting the gravitational acceleration, if I'm plotting the graph of the gravitational force versus the distance, I will get the graph like this, right? So I can have Fg here and I can have r squared here, right? You can see that at this point over here, I can see that that is the gravitational force, and you can see that I have the distance here. If I'm reducing the force, let's say I'm reducing the force over here, now you can see that the distance also increase, right? That's very important to note. Okay, so that's the first step. All right, so now let me just draw this to be practical, right? Let's say we have two masses, because when we are talking about the universal gravitational law, it is the law that is based on the mass of two objects, right? So it's the law that is based on two objects. We also call this force a non-contact force because it's based on two masses of the object, right? Let's say I have the first object, right? I will say this is m1, and the second object, right, I will say this is m2, right? Okay, now the distance that I am talking about, which is the distance, right, I will not use the distance that is between from the surface to the surface. No, what I mean about that, I will not use the distance when I'm doing the calculations. The distance that I want is between their centers, right? So when I want the center of this mass and the center of here, so the distance that I'm looking for is that distance, right, from their centers, right? So that is r, which I want, right? So in this universal gravitational law, the formula that you can use to calculate the gravitational force is Fg equal to m1 times m2, or times g here, right? G, okay, I will define the force, I will define the formula over r squared, right? So let's now explain the formula, right? So this is the formula that you can use to calculate the gravitational force, right? The universal gravitational force, right? Okay, so this universal gravitational force is also same same as the weight, at some point, right? Okay, so G uh, G is the universal gravitational constant, right? Which is always given, right? When you are writing an exam, you don't need to like remember this because it's the constant that is given on your formula sheet, but is it's equal to the 6.67 times 10 exponent negative 11 Newton meter squared per kg squared. Okay, so it's not like you have to remember this will always be given, right? Okay, so but the distance that I want you to understand, that is the distance between their centers, which is this r, right, from their centers, and this is the mass of the first body, and this is the mass for the second body, right? Okay, now there is an important thing that you guys I want you to understand, right? So firstly, this is the formula, right, that you can use to calculate the universal gravitational force, right, by knowing the mass of the first body and the mass of the second body and multiplying that with the universal gravitational constant and divide that with the radius, which will start from their centers, which is that's the radius over here. Now let's say we have let's talk about the earth, right? Because there's a formula that is important that you guys I want you to understand. Okay, so this is the earth, right? So at the center of the earth, right, this is the center of the earth. If I draw the line from the center of the earth to the circumference or the surface, so this is the radius of the earth, right? Okay, so the earth, you also have to know that the earth has the standard radius and also has the standard mass, right? And also you don't need to worry yourself about that, because that will always be given on your formula sheet, right? When you are writing an exam, you can always look at the back of your formula sheet, and you then see the mass of the earth. The mass of the earth is given as 5.98 times 10 exponent 24 kg, while the radius of the earth is given as 6.38 times 10 exponent 6 meters. Now I want you to understand this. In a formula sheet, they can just talk about the earth, and they can just talk about the earth, and they will not give you the mass of the earth, right? Because they understand that you can always find that at the back of your formula sheet. You just need to go on your back on your formula sheet and take the mass and also take the radius, right? Let's say now at the surface of the earth we have someone, right? Let's say we have the person that is here at the surface of the earth, right? Now let's say we want to calculate the gravitational we want to calculate the gravitational force, right, of that is exerted by the earth on this person. Okay, now I want you to note that if you note something, if you take the distance from the surface of the earth to this person, the distance would be 0. But because let me just draw this person to be quite big. But because let's say this person is on the surface, but because we always take the distance from the center of this person, right? If this person is on the surface of the earth, let me try to draw this person be on the surface of the earth, bear with me. If this person is on the surface of the earth and I'm starting from the center of this person to over here, that means R will be the radius. So if I want to write the gravitational if I want to find the gravitational force, which is Fg, will be equal to G times the mass of the earth times the mass of the person, right, divide by the radius of the earth. squared, right? Because you can see that the distance between this between these two objects will be the radius of the earth, because we have to start from the center of each object, right? And you can see that if we are taking the distance from the surface to the person, that distance will be 0. But if we are starting from the center of the earth to the person, the distance that you will be using, it will be the radius of the earth. Okay? Now, I want you to understand this now, right? Now, there will be the stage, right? There will be the stage where you're supposed to understand the gravitational acceleration, right? Where is the gravitational acceleration came from, right? Because you have to know that all the objects in the earth, if the object is on the earth, they always experience the same or the constant gravitational acceleration of 9.8. Okay? Downwards, right? Now, let's say now we want to calculate, because if I'm talking about the weight of this person, right? If I want to find the weight of this person, right? So the weight of this person, right? The weight of this person is equal to the mass of the person times the gravitational acceleration, right? Which is 9.8, because this person is still on the surface of the earth, and I want to find the weight of this person due to earth. Okay, now this weight of this person is also equal to the gravitational acceleration, because that is the force of gravity that is exerted by this person on the earth. Okay, so if I'm substituting this with the mass of the person times the gravitational acceleration, equal to g times the mass of the earth times the mass of the person over the radius of the earth squared. Okay, then here I will have if I'm dividing, this will cancel that, and I will have the gravitational acceleration will be g times the mass of the earth over the radius of the earth, right? So I want you to note something here. As you know that if you just plug in the values here, you plug in the constant here, which is 6.67 times 10 exponent negative 11, and also plug in the mass of the earth and the radius of the earth, you have to get the ratio of 9.8, right? But now, okay, before I explain this, what does this actually mean? This means that the gravitational acceleration doesn't depend on any object that is in the earth. That tells you that all the objects that are in the earth, they experience the same gravitational acceleration. Okay, in a test or an exam, they can just say, prove that all the object in the earth, they experience the same gravitational acceleration. You just have to do this, and you can see that the gravitational acceleration doesn't depend, right, on the mass of any object that is in the earth, right? Okay, now this is what is so much important to do this. So this is part 1 of this video, right? So I will don't forget to go straight to watch part 2 of this video, where we'll be doing the example of this, right? But for now, don't forget to subscribe on my YouTube channel, right? And also don't forget to go to have a look at part 2 of the video. All right, ciao for now.